Hey guys, my name is Pratik, and today we'll see how deep learning is used to classify photos at Yelp. Most of the content on Yelp we see is user generated. When users are allowed to freely upload on a platform like Yelp, quality control is a massive issue. Photos are a very important part of Yelp's business model. The photos provide a rich window into local businesses. One way Yelp is trying to open this window is by building a photo understanding system, which allows to create semantic data about individual photographs. The data generated by the system powers the recent launch of tab photo browsing as well as the first attempt at content based photo diversification. So we'll see how Yelp built this photo classifier. So Yelp used deep learning to classify these photos. One can imagine a variety of ways to tackle the ambitious goal of holistically understanding these pictures. To help simplify Yelp's problem, Yelp focused initially on only sorting photos into a handful of predefined classes, the ones you see here. So this is specifically targeting restaurants. You have classes like food, drink, inside view of the restaurant, the outside view, and the menu. To develop a classifier that can be put into one of these groups, it was needed to first collect many photos with known labels. They collected this information through various ways. The first one being the photo captions. A good number of menu photos have the word menu in their captions. Similarly, we can find photos with title like sushi or burger that are likely to be food. For the former, Yelp had to worry about false positive because it's not uncommon to see food or drink photos whose captions are like, let's say, best on their menu. This is definitely not a picture of a menu, but it's talking about a food item. And as a result, some cleanup was necessary. To aid them in identifying food items, they relied on Yelp's internal menu structure, which is used to maintain business list of food items. It is found that matching food items from the list to captions of photos yielded a data set of high precision. The next one is the photo attribute. When uploading photos to Yelp, users are allowed to mark a few attributes about the photo, such as is it the storefront? They are not always accurate but serve as a good structure for candidate photos. The way Yelp used was crowdsourcing. Yelp ran additional tasks through a crowdsourcing partner to correct the guesses of the classifiers of what label should be applied to each photo and then collect more inside and outside photos of the restaurant. It was found that this led to generally good quality labels at a reasonable cost, both in terms of money and time. So once they had the data labeled, they employed the classifier. So this is the classifier. They used convolutional neural networks in the form of LXNet to recognize those classes. CNNs usually consist of deep stack of multiple convolution layers, rectifier linear units, pooling layers, local response normalization layers, and fully connected layers, as in convoluted feed-forward neural networks. So they used Cafe framework to deploy this classifier. Cafe because it is easy to use, performant, open source, and under active development. To address Cafe's software dependencies, they've wrapped the whole classifier in a Docker so that it could be more easily deployed. Inside the Cafe classifier, this is like the baseline for the whole Cafe framework that's using the Cafe framework. This used to basically, this is like an abstraction where you just input the image. The classifier used to run and appropriately label the photo and then give you the classification result. It was found that it had a precision of 94% and a 70% recall on a batch of 2500 photos, which is pretty good for a start. Then we can see what are the applications of this classifier. The first one is a REST API service that they created. Yelp uses a service-oriented architecture, and they made a RESTful photo classification service to support existing and upcoming Yelp applications. So basically, to reuse the classifier, Yelp just wrapped it into a RESTful service. The main applications of the service are as discussed below here. So you basically give the restaurant as the classifier ID, and then what business are you targeting, which location, and what are the kind of categories of photos that you want. So you give all these three to the APIs and it'll return you the photos. So this, because this process is very very lengthy, it basically is not done on runtime. It is basically done on a daily basis, where a batch is created and then it is passed through the classification DB and then it goes to the clients. The next application is a cover photo diversification. So Yelp has cover photos for each restaurant. um, Diversification is needed on these businesses because not everybody wants to see the food items on the cover photo. People might want to see how the ambience is, or how the outside looks, or is there parking available. So a diverse photo, cover photo has to be selected. So Yelp uses this diversification algorithm to bring photos from different categories here. The next application is a tabbed photo browsing, where again you browse for a particular restaurant and you get a ton of photos related to that restaurant. Again, here you do not want to see pictures of food, or just pictures of the interior, or pictures of the outside. So it has to be a collaboration of all these three things, and hence this classifier helps us to collaborate these resources and make sure that there is a diverse set of photographs available. So what is the future scope of this application? Obviously, no machine learning algorithm is perfect. So how is Yelp using the users' help to train their models? So basically, they have options like these, which can be selected if the user finds that the photo is not appropriate, or it is in the wrong category, or it does not match the business. So this will help the business to understand that, okay, the tagging has not been done properly and cleanup can be done. So that's about it. I hope you found this very informative. Thanks for your time. This is the reference. This has been taken from the Yelp's engineering blog.